Hello, everyone. So I'm going to have this talk about comparing TC-Flower and RTA flow integration in OVS. Just a quick introduction. So I'm David Marchand. I'm working on DPDK mainly. I'm a maintainer for some years now. I've been involved in DPDK for a couple more years than maintainership, but that's a different story. What I've been involved with is DPDK and OVS, especially the integration of OVS with DPDK. So we have a few people here working on OVS, trying to make best use of RTA flow and DPDK in general. The goal of this talk is mainly so to share some feedback of this integration of RTA flow and make people aware of where RTA flow stands when compared to TC-Flower, because TC-Flower is what we hear a lot about when OVS is involved. So first of all, some context, packet processing and offloading. Why does it matter? Well, everyone is aware that as more time passes, we have more and more bandwidth. So 10 gigs was already fine in terms of handling packet processing, but going with 100 gigs and more, it's not possible anymore. Additionally, pushing packets through a host when you are trying to process this packet in a guest, in VNF and CNF, is not efficient. You are spending power and processing units in just to move packets around when you could achieve it with hardware directly. And using those processing units is also consuming a lot of power, and as we are all aware, we want to save the more power possible. So offloading is something important as it's one way to address those issues. As far as offloading technologies are concerned, so what do we have at the moment? In the kernel landscape, as I said, it's TC-Flower. It's one framework that is been around for a while. There is one main implementation with the Mellanox driver, the MX5 kernel driver, and some other vendors are trying to implement some part of it. On the user space landscape, so we have RTA flow with DPDK. I'm not aware of many user abstraction of hardware offloading in user space, actually. I think we are the only ones doing this, I guess. Other approaches, so there is some, I'd say emerging because it's still a work in progress. There is nothing really usable in production from a point of view. With eBPF and XDP, trying to offload stuff is still something that is being discussed, how to let's say, have a model for this. Another approach is P4, but as we can see, it's still unclear how to use it, either in the control plane or the data plane. I'm still not clear about where the pieces are going. So with regard to this offloading framework, so why did I choose OVS? Well, it's cool to have some offloading technologies, but it's not only about pushing a packet from a port to another one. Usually when you are doing packet processing, you need some stack and more context to animate those processing. And well, there's not many open source projects that are doing this kind of stuff. There's a Linux kernel, there's OVS, and well, there's also other projects, but they are not as active as the kernel and OVS. And additionally, I'm working on OVS, so it's a good point to look at it. So yeah, basically, OVS has integration for TC-Flower and RTA flow. TC-Flower integration has been discussed in previous talks. In DPDK Summit, we usually talk a lot about RTA flow. We have talks about RTA flow in DPDK. But it's I think, the first time that we are talking about RT4 plus OVS explicitly. So let's have a look at this integration. I used a rather simple setup with some Intel server with a good CPU. And I went with the MLX5 driver. Why this driver? Because basically it's the only one that has an implementation in both kernel and user space, in both TC-Flower and RT-Flow. The NIC I used is CX6 NIC because it's the only one that has the main capabilities in hardware. And for reference, yes, I focused on the OVS 3.1 release because it's one of the stable one, and we focus on LTS integration only with the OVS. So setting this was rather easy at first, let's say. Mellanox drivers are relying on a bifurcated approach, so you have two parts. You have one part in the kernel, and DPDK is using this kernel framework to program stuff in the control path. Enabling hardware offloading was rather simple too. It's the same approach, well, the same configuration for TC-Flower and RT-Flow. You don't need to do anything special, except that you need to switch your device to switch dev mode via some IP root command. I can give the details if someone wants, but it's rather easy. Just a one note is that is specific to Mellanox drivers, because if you are using RT-Flow drivers for hardware relying on VFIO or other frameworks that are pulling the device out of the kernel, it would have been a bit different. So once you have enabled hardware offloading, for TC-Flower, that's done because you already have your net devs. You can pull them in some OVS bridge and go with packet processing. For DPDK approach, you need to set up DPDK as usual, meaning that you need to set up some huge pages, allocate some CPUs, and do your usual configuration. So it seems easy. It's the same for both frameworks. But wait, the first complication. With MLX5, you need to have an explicit allow list to identify every representative that will be used in the application. So this kind of stuff is a bit surprising when you know that OVS can plug devices dynamically when you have OVS already running. But here you need to know beforehand that you will use those devices. And changing this configuration requires restarting OVS. So that's the first thing that is quite non-intuitive when you are first trying this kind of setup. Another quite surprising stuff. By default, when you start OVS in RHEL or some Red Hat software, OVS is running as a normal user because we want to separate accesses to resources. But here, it's not working by default with Mellanox drivers. You need to run as root because there are some special allocation with ICM memory, if I remember correctly. Yeah, okay. You'll have to. Oh, that's a good news. Okay. That's great. So yeah, you need to run as a root user. There were some small changes on this aspect in OVS 3.2 because we added some ways to keep capabilities. But if you tell me that we don't need this anymore, that's perfect. Okay, we'll see. Yeah, and one last point is when doing some tunnel offloading testing, you will have some quite surprising results. Well, it won't work by default. tunnel offloading, as you know, Ori, we need quite some, I don't say black magic. You need to pass dv x meta n3. That's a good value. Okay. So yeah, and by the way, the tunnel offloading is experimental, and that's a bit of what I'll say just after. In terms of features, so TC-Flower has been, I'd say, armed. Well, it was designed, written with VNF and OVN in mind. In that, we have tunnel offloading for OVN, we have contract support, and a few other actions that are offloaded to the NIC, because that's what is used in this software. On the other end, on RTFlow side, we are missing a few pieces. So contract support for OVS is absent. There are some bits on DPDK side, but there is no integration on OVS side, and I'm not sure how it would work, if it can work. So that's something I'd like to have some feedback on it. Additionally, the tunnel offloading API was experimental so far. So I did some enhancement on this topic. There is still some more work to do, because there was some feedback from the OVS community. And this is an important point from a point of view, because this kind of stuff was is some feedback that was given after the DPDK API had been written. It was the feedback came a few months later, and we are still discussing it to get a proper API that is used by the application in the end. So that's something that we must keep in mind, is that it's cool to have a good API, but it's even better when the application is happy with it. Okay, we agree then. Last thing, so yeah, on the tunnel offloading side, there is Geneva offloading that has been proposed for OVS. It's still being well, it's not merged, and it would have some maybe rebase need requirements before merging. As a last comment, for both TC-Flower and RTFlow, contract is good, but there's no ALG support. And having no ALG can be an issue for people wanting to do full state tracking, full contract full state. Yeah, so I did some performance measurements. So on the throughput side, well, there's nothing really surprising. We have good performance with TC-Flower and RTFlow. Once your flow are offloaded, there's nothing to do more, and so the hardware is capable of handling this fine. I have some numbers like, well, it's more than 50 million packets per second. But one aspect that is important too when you are offloading stuff to your hardware is the rate at which you can update the rules that you push to the hardware. So I did some measurements with perf mainly, making sure that those flows are getting pushed to the hardware. With TC-Flower, I managed to achieve around 30K flow per second updates. RTFlow is going to almost 100K. And I put two other numbers here, is that the TCL2 test is just a reference without OVS. It's using TC-Flower without OVS. So you see that that's not really OVS that is limiting the rate of recension in the hardware here. But on the DPDK side, we see that there's probably a limit that we reach with OVS, because using the test tools that is in DPDK, we can achieve almost yeah, twice or even more, depending on what you are testing. One final note on this topic is that by default, OVS will try to offload all threads, all flows through one thread, but you may assign more resources to push more flows to your hardware, and with this, I managed to get more flows per second in the hardware. So all of this, it's great. I have a great number, so RT flow is better, but is it enough for everyone? Well, in my case, I'm focusing on telco stuff, and usually when you think about 10 gigs traffic, the feedback I get is that you're expecting 1 million flows continuously, and 100K updates per second for 10 gig traffic, 10 gig of traffic only. So when you look at this, it would mean that RT flow is just okay for 10 gig of traffic. So if we want to go to 100 gig, there is more to, well, we need more. And maybe at this point, we will have to discuss if we can go with some new API, because there's something else in DPDK, and yes, that's the talk that Ori gave last year about achieving something like millions of flow per second. I have the link if you want. You achieve, I think it was 1.5 millions. But yeah, I guess it's similar to what you've benchmarked in the past, I guess. Yeah, finally, debugability. TC Flower is in the kernel, so it has a lot of external tools that exist that makes it easier to debug when you have issues. On the other hand, RT flow is quite poor, let's say. You have nothing in the API to list rules. You have nothing to extract information easily in generic way. There is a dump API that gives you xdump in a file, so it's not that good. And yeah, that's something that I think we are missing. It's software implementation of RT flow, like something that we could maybe hook on some virtual drivers and use it as a reference for the APIs, so that people can compare their drivers against. Testing, yeah, on testing and CI. So there's a lot of stuff that is done on OVS side for TC Flower. So yeah, it exists and it is run regularly. But on RT flow side, so for OVS, let's say, there's nothing at the moment. I'm trying to get something in our existing CI. We'll see if it's easily done. There is still, yeah, there is something in DPDK itself, in DTS. UNH is supposed to, well, they have some task on this topic. We will have to maybe look at what can be done. I'm not sure, I did not look at what you have in store, so we'll see. And well, that's pretty much it. So as a conclusion, let's say that TC Flower has more features because it's been around for maybe a more, longer than DPDK. And especially because the integration has been done with OVS before RT Flow. RT Flow is a promising solution because it has a better performance, but well, it has some raw edges. It's not easy to come up with a setup that works at first, as I pointed previously. Maybe something that we could enhance is documentation. I tried to post some patches to help users when tunnel offloading is not working, for example, this kind of stuff. And I guess what is really missing is involvement of other vendors. I've noticed that there are some people working on OVS side now for enhancing support for, I think it's the SFC driver. That's a Solarflare driver, I guess. Yeah. And yeah, what you're missing, really missing, is tests and ideally multi-vendor tests. And well, that's it. I hope you have a better idea, and well, let's discuss it out of this session.
I don't know how much time we have for questions. few minutes? Just a couple minutes. So thank you, David, for this great feedback. I think that's very important to talk about all these things. By the way, we will have a special session this evening to talk about RTE flow. You insisted a lot on MLX5.
Yep.
Because that's true, MLX5 has the best coverage in RTE flow. In general, most of features in RTE flow are added when the feature is added in MLX5 at the same time.
It's not always true, but it's in general
most
true.
of the time. Yeah.
Yes.
And that's bad. That's bad to have a single vendor doing most of the work on a component. That's bad because you said it. We lack some tests, maybe we lack some documentations, things may be difficult to set up. And because that's something quite new, and there is one vendor doing most of the things, when a customer needs to use it, what happens? They will just ask the engineer in the vendor company, and the vendor company will solve the issues, and at the end, issues are maybe not solved in upstream. That's why we need to have more users, more implementers now to use RTE flow in DPDK.
Yeah, that's not a question, but I agree.
No, yeah, sorry, I'm just insisting. Just insisting. No question. Already.
I don't have a question, but I do have a comment. Yep. I have a lot of comments, but that's regardless. What DPDK, especially in the RTE flow, I'm not talking about different parts of DPDK, is missing the comments, okay? Like you said, most of the cars is an NVIDIA, for example. We're talking to our customer, we're getting their feedback. OVS has its own feedbacks, but it's not shared. I have my mailing in the mailing list, and I have everything, and you know, it's nice to get all the slides that you did, even though that most of them are known to me in some way or another, to talk and discuss, and let's try to do what we can, or at least plan something.
Yeah, okay, sure.
Not to wait to a summit to do that.
Well, I posted a few patches over the months.
Yeah, but
you could expect I would have something to show after, because it's an accumulation of what I posted.
I think your explanation is very good, because it shows the problem, and you're all in favor of it.
Okay, thank you.
Sorry, quick question on the rule insertion performance.
Yep.
Do we know where the bottlenecks are? Are they on the CPU side or on the...
No, I did not go this far. I did not look at what part was consuming most of the time. So no, okay. I would have to look more, but I did not have time for this.